Do you know?
No,
No, it's not.
no.
How many times bigger is the sun than the moon?
Did I say it was that? Or are you trying
I'm
to get this out
asking you a
to throw at
question.
me?
Hey,
Dave,
Rob,
hang on.
Rob, I'm
15
asking you a
seconds.
question. I'm asking you a simple question. In the heliocentric model, what's bigger, the moon or the sun? Am I talking to a
Tim,
5-year-old? What's going on here?
no, we're talking different languages,
Rob,
Dave,
I'm
and I think
asking you
you're
a simple question. In the
because there's nothing I could ever say to you that would convince you otherwise now.
That's not true. Say something coherent.
You're, you're offering 2 Bitcoins, and
Three
it's like you
Bitcoins.
have,
Get your shit straight,
and
man. So what's the story? What are we doing here tonight?
Um, I'm not 100% sure. I know Chuck Fall and Robbie are kind of with the libertarian Greens, um, and they want to, I guess, explore the whole flat Earth concept here. I guess I'm not exactly sure what they're going to do. Are they going to try to argue about it? I don't know.
Are you a flat earther?
Yeah,
Okay.
here's the map. Yeah, no, it was all the way back in fairly early on when it all started coming out. I found out about it. So, oh, there's Robbie, I think.
You got two guys there.
You know what? I will get closer, and I want to say, Dave, thank you very much for taking the time here to talk to us. How is this? Is this better if I'm
That is
closer?
awesome. Why don't you stand there? I'm standing.
Aim your camera down a little bit, Robbie.
You know, the problem is you can't stand because you might fall over because the earth is spinning.
Well, wait a minute now. Hang on. Hang on. That doesn't make sense to me, but I would really like to get into that
All right, no,
because
no worries. You can sit if you want. No, whatever you want to do, man. No worries.
using that same logic, if I were to jump on the back of a truck, wouldn't I fly off the back? If it were like a moving van, would I hit the back door or would I land in the same spot?
Well, I was just making a joke about the earth spinning and dropping. You know, the truck, you want to compare the truck to
Well,
the
that was
earth,
a
you got to,
serious point, Dave, and that's why we're here.
yeah.
Conspiracy theorem. Conspiracy theorem here. Do you know what the word theorem means? I'm blocking here. Theorem is the accepted theory of, like say there's math and such, right? And so what we have here is a group of people that I highly respect, and we have really good conversations about a topic that's come up very strong recently. And it's something that I think that we should talk about because people on both sides turn things into jokes. They turn them into like, who Globe, you make Globe Face and the debate with Kyle and Witsit and all these people. And is
I'm
this good
listening.
if I? Tim,
Still here.
I like that map. I really like that map.
Oh, good.
So I don't know. I want to have a serious conversation. I'd actually really like to believe in flat Earth,
Well,
and I found compelling evidence, such as the fact that you should be feeling somehow the Earth spinning.
well, you know what? The argument there is, everyone's programmed to say, well, on an airplane, I can drink a glass of water and I can walk to the bathroom. I go, but if you want to compare the airplane to the slowest motion of the Earth, you'd have to double the speed of the airplane. You'd have to have it nose down at 1 mile per minute. And then
But
you'd have
that's
to take out the outside shell of the airplane because there's no shell over the Earth, right? Because we're
but that's
spinning at 1,000 miles an hour, we're orbiting at 66,000 miles an hour, and we're chasing the sun at over around a half a million miles per hour, corkscrewing through space. So none of those are comparable to an airplane because an airplane is enclosed and it's going at a steady speed in a straight line. If that airplane takes the slightest turn, you feel it, the slightest turn. But if it nose down a mile a minute, you'd shit your pants and you'd throw up, right? But that's what the Earth is doing all the time. And we're speeding up and slowing down, and we're spinning as we're going around corners. None of the motions of the Earth are a straight line, but we don't notice them at all, right? Just to give you an idea of what the Earth is doing, which is so ridiculous, right? This is the hypersonic sled track. It's going to go by a Mach 8.6. Watch it, because you're not even going to be able to see it. Now, that's fast. You can't fathom what twice that speed is, but you have to believe that we're going 10 times that speed around the sun and 100 times that speed chasing the sun. But we go outside.
Hang on, Dave.
And we have water like this.
Dave, I understand these points and the argument that you make with that. But the problem is that this has been going 11,000 or 60,000 miles. You want to speculate the globetards suggest it. It's going that fast from creation. And now, like from the moment that it's been going, it's never changed.
You know the difference? That's not true because in your model, we slingshot, we speed up around and then we go out, we slow down, and we come back and we speed up. Now, none of these motions are linear motions. If we were going 1,000 miles an hour, 1,000,000 miles an hour, 1,000,000,000 miles an hour in a straight line through empty space, you have a good argument. How would you know? Everything's relative. Everything's already moving. But as soon as you change that trajectory, an example could be you're in a car on a perfectly smooth road, great car, smooth, and you're going 100 miles an hour. You have a dinner plate filled with water, no problem. If that car speeds up or slows down the tiniest bit or takes the slightest turn, that water is gone. But we're doing crazy maneuvers all the time, speeding up and slowing down. So saying that it's been going since eternity, that's just words because that doesn't mean anything because we're changing speeds all the time. We're changing our trajectory. A straight line is different than a curved line. Curving is acceleration.
Two things real quick. Hey, Tim, are you recording this?
Am I recording it?
Yeah.
I don't know.
You guys can hit record. I'm also recording, and I can send you the copy if you want, whatever you guys want.
I'm so ignorant to this, and this is something entirely new. But
no problem.
Dave,
listen, Rob, I'll record it, and I'll send it to you guys unedited. You can have the whole thing.
Dave, you rock. I really love this because here's the thing. My problem is that there's this thing called gravity that I've been taught about, right?
Yeah.
Gravity, which the Michelson-Morrison experiment, which I would say is a very valid argument for flat Earth, such as the three-body problem, which are very serious things with physics. But I think that just suggests there's something more to this world than what, we understand. And here's my critique about, not my critique, but here's my problem with the whole flat Earth model is how is it you can explain that people can see the crux constellations in the outer rim of South Africa and South America all at the same time in the same sky looking south.
So do you want to talk about gravity or you want to talk about the Southern Cross? Which one first?
Clearly you don't even believe in gravity, Dave. We don't need to go there.
You just talked about gravity. I'm willing to answer either one of those things. So which one would you like the answer to? The Southern Cross?
The one I asked.
What's that?
The one I just asked.
Well, you asked about gravity first, and then you asked about the Southern Cross. You want to do the Southern Cross?
I told you there is this thing called gravity, which we don't quite understand. It's the weakest force as far as physics go, where quantum mechanics starts to break down everything into where they say there's this supposed dark matter, which may or may not exist. It's their best explanation at finding why the gravitational bodies have done this. And all I'm suggesting is how does that mean that the Earth is flat when I'm looking at people who have recorded the Crux constellation in South America? This is my question. How can you see the Crux constellation in South Africa and Australia looking south at the same time?
What does the Crux constellation being viewed from those two locations have to do with gravity?
Nothing.
Okay, so which one do you want answered first?
The one I just asked.
You started off 3/4 of your
I don't
statement was
care that I
about
thought
gravity.
Answer, how do you see the South, this Crux constellation? That's all the question, not gravity. We don't even believe in gravity. So how can we talk about it? Let's just go into the constellation, because how do you see that?
Okay. So you're following a piece by a failed musician who calls himself a professor, and he says you can see it at the same time, looking in these separate directions, the southern constellation at the same time. Well, what he doesn't realize is if it's midnight here, it's noon over here, so you can't see them at the same time, looking in the same direction. And this actual observation, I'm going to explain it to you, but you got to listen to the answer because I can't really hear you because your voice is so quiet. So raise your hand if you want me to stop talking. All right, go ahead.
There's been a video by the Globey McGlobeface.
I
who
know it.
found that
I'm going to address it right now.
So how did they do that looking at the same place at the same time?
Okay. So he's claiming that they're looking in three opposite opposing directions. When in reality, there's only a certain day of the year where those three places at the same point in time, not same time of day, that they can see.
Just two.
What's that?
It's just two.
Okay, well, I'm showing you three. It makes it even worse. Okay. And they're not looking in the same direction, right? They're actually looking in, they're all looking southwest. Well, this is southwest, this is southwest, and that is southwest. They're looking in different directions. This actually, if you understand it, proves the globe. It doesn't work the other way. So
it does prove the globe.
It actually doesn't. It actually proves the globe, because if they were underneath looking at it at the same time, they would have to all be looking south, right? But if they're looking southwest, they're all looking to their south and left, south or south and right, south to the right, south to the right, south to the right. So if you look at that, if I go back to this, where is it? If I go back to this, so
I just had a quick question.
This is looking southwest. This is looking southwest. This is looking southwest. They're claiming that they're all looking southwest, but when you put it on a globe, that doesn't make any sense at all. They're not looking at the same stars. The stars are over here. This guy's looking over here, right? It actually, if you understand it, it proves flat Earth. Go ahead.
Well, that was the first time you said it proves flat Earth, but I mean, it wasn't that they saw it over into the southwest, it's that they saw it higher in the sky.
They don't see it at the same time. They see it at different elevations because they're at different places, right? And if you look at it and if you understand
what was the
how we see the sky, it's called our azimuthal grid of vision, right? It's what the globers use to explain how you chart out stars. You get your direction, you get your azimuth, and you can chart out everything in a azimuthal grid of vision. And when you chart it all out, it proves the globe to be wrong on this observation. Now, there's other videos that are way more detailed than I'm going over now, and I could point you to those, and you can check them out yourself.
Show me the South constellation as you see it, because again, you haven't answered it well to me. I'm not convinced that flat Earth model is real because I don't understand, because the other video, right, shows that these people were looking south and southwest and both at the same exact time viewed the constellations at different points of their realm.
So
in your outer rim, you're bringing up the.
Here's somebody in Santiago. They're looking southwest, which is this way. Over here is somebody in South Africa. Okay.
What's that? About the constellation. We're talking about the constellations.
I'm telling you. Well, I'm pointing the direction. They're pointing the southwest. It doesn't work once you understand it. But here's the other thing. Why are you looking at the lights in the sky where we can prove they're not what people tell us, giant burning balls of gas at trillions of miles away, and claiming that proves the shape of the Earth? That's like looking at the lights in your ceiling and claiming the shape of your floor.
I got to tell you my background. Can I tell you this? Because I love you. I love this. This is really great. Spider and Tim are here. These are two very highly respected people I have in my life, and I think that these conversations are very important. And I just want to say I really appreciate you having this conversation. And I don't want to be the main person taking over. I don't know if anybody else wanted to bring something to conversation here. I was just going to share my back. Go ahead, Tim.
Is Chuck Fall jumping in?
No, Chuck's traveling, unfortunately.
Okay.
So,
all right.
Let me tell you something real quick. I've from a very young age, I had a telescope, and I was always looking up. And you just said that you won't get the answers from looking up. And every time that I talk to a flat earther, my whole thing is I know we're spinning because I'm looking up. I'm not looking down at YouTube videos. I'm not looking at all this.
So when you look up, what do you see that proves the Earth is a globe?
When I look up, well, for one, the South constellation, the Southern constellation, which are viewed from all the points, which I understand your answer.
So what is the Southern constellation made out of? What are those lights that you're seeing? How far are they? How big are they?
Specifically, the crux.
The crux. It's a series of stars. I think it's 6 of them. What are they, and how far are they?
The 13th constellation around.
Okay, the 13th constellation. My point is, you're looking at a light in the sky. How big is it, and how far is it?
Well, okay, so compared to that star, those stars, which I don't ever get to see because I'm in the northern hemisphere, I only still see Polaris, and I only see like the Northern Dipper, which points to it, and Orion's Belt, which is around the area that I can see, right? So I can see those stars and Betelgeuse with my telescope. So now here's the thing. When I look at a planet, I can clearly see that it's a planet.
So you're going a lot of different places here. So first, we'll get back to why you can't see Polaris in the south. You want to talk about planets? You look.
Dave, you asked why it is I believe that the Earth is flat when I look up, and I just told you.
Well, you gave me a whole bunch of things. Which one do you want me to answer first?
Here, I'll answer this one, okay? How is it I can look up at Jupiter and see the 4 Galilean moons literally orbiting around it? I can take binoculars and see the red spot, and I can see the little 4 Galilean moons. And if I look up there a couple hours later, they'll have moved. But I can't see that with my naked eye. Why would they do
you see planets like this?
No.
Okay. What do you see? Do you see planets like this? Right? This is Mars.
No, I have a better telescope than that. That's actually, what is that, a P900 or a binocular with a camera? What is that?
That's a P1000. Do you see planets like this?
That's a handheld camera, Dave. I have a telescope.
I get these same pictures. Okay.
Better.
So
Jupiter, right?
Do you get a picture of Jupiter this good?
No, that's better than the telescope I have, but I have a better telescope.
So let me ask you a question. Where did this video come from?
I don't know. NASA?
It's from NASA. I'm asking you questions. Let me walk you through this. Okay. This is from NASA. Hold on. I can't hear you talk when I'm talking. So you got to, I don't talk forever, but I got to make a point. You want to say something first?
Point is not answering the question about how it is that we can see Jupiter's Galilean moons go around it.
I'm going to answer that.
Nothing to do with NASA. I'm not. That's CGI for all I care.
Well, do you think NASA gets a better view of Jupiter than you do?
I mean, they got 3.
So let me ask you a question. When you look up at Jupiter, you see.
Yeah, maybe.
You see a light that has a spot on it. I've seen it. It has a spot on it, but it's a light. That's all you know about it. It's a light. And then you see some other lights around it, the 4 moons. You're told that they're moons, but the only evidence that you have, the only thing that you can truly say is that they're lights. Now, have you ever looked at how reflective a rock is?
Dave, these lights have patterns. They go into retrograde.
They go, absolutely. That doesn't mean that they're planets. That means that they're lights that go into retrograde.
Exactly. They go. Our ancestors have tracked this and known and have been able to predict total eclipses because of these movements and patterns. So how are they not significant if they're just lights?
So I'm not saying they're not significant. I'm saying that these are lights in the sky that are provably not what you're told. Now, okay, I gotta make a point. You gotta let me make a point. Okay, I haven't made one yet. We're all over the place. Okay, you asked me 5 different questions and you don't listen to one answer.
I can't understand your answer, Dave. I'm trying to understand.
Because you're not listening. You're putting words in my mouth. You're making up things that I'm saying. I'm not saying I think that they're very significant, way more significant than you think. Okay, but when you look up, can you see Jupiter with your naked eye? You want to say something again?
Yeah.
You can.
I can see Jupiter.
Why can you see Jupiter with your naked eye?
Because I know where it's like, I know what it looks like.
Well, is Jupiter a sun?
No, it's a planet.
It's a planet. It's a gassy planet.
With 4 visible satellites with the binoculars.
So Jupiter, I'm trying to get some baseline here. Okay. Jupiter is a gassy planet. Do you believe that?
It's a planet that I can tell is different from the other stars.
Okay. When you look up at Jupiter in the sky, it's pretty damn bright. It's actually very bright right now. Okay.
That's why
hugely bright. Do you know what the inverse square law of light is? It's okay if you don't. I didn't.
So what you're going to suggest is that the sun isn't bright enough for the light to go to the Jupiter and then come back to us.
Correct.
How do you know?
Because the inverse square law of light, which is a scientific law.
Isn't that here on planet Earth with this atmosphere?
So
let me ask you this, Dave.
So just hang on a second.
How does the sun burn? No. How does the sun burn?
I don't think it burns at all. I don't think the sun is a physical object, but I'm not going to make any claims because I can't go there. I can't hear you when I'm talking, by the way. So you gotta learn just to listen for a second.
How is it that you can apply that study to a sun that's a nuclear fusion reactor? It's
Straw
not
man.
the same.
How do you know it's a nuclear reactor?
It's not a burning candle.
And so because it's not a burning candle, it's a nuclear reactor.
The light reverse infraction, right?
So you're under the belief that once upon a time there was nothing, it exploded, and then all of the gases coalesced to make giant balls that turned into nuclear furnaces or whatever you want to call it, and left a void in between all of them. So you got nuclear gravitational fireballs fissioning or whatever in a vacuum. How does that happen?
I mean, that sounds more likely than them just being fake lights. I don't understand.
I didn't fake lights. Again, you're putting words in my mouth.
But here's the thing. That's, again, what we were talking about was Jupiter and the fact that I can see the 4 Galilean satellites moving around them.
So you can see 4 lights moving near or around. I think they're going around, honestly. Jupiter. But you don't know what Jupiter is. They tell us Jupiter has more gravity than all of the other planets in our solar system. But Jupiter is made out of 99% hydrogen and helium. Here on Earth, hydrogen and helium defies gravity. So how much do you need to create gravity more than all of the other planets combined?
I mean, more than I can really fathom, Dave.
Well, it's more than you can fathom because it's unfathomable, right? It's literally unfathomable. So here, let me ask you a question. Let's say you were looking up at the sky or over on the horizon and you saw this. Is that a planet? Is it a sun? Is it Jupiter? What do you think it is?
I don't know. The police coming after me.
Well, it looks spherical. And if a book written by the Rockefellers told you that it was a moon or a small sun or a planet, you would just assume it. But if we bring it closer to us, you can see that it's not. It's a train, and it's not even a sphere. It's a whole array of lights. Okay?
Okay, good. I don't understand what that has to do with the southern
My point is, unless you can touch it and measure it and know the size or the distance, you can't make any claims about it, right? It is scientifically provable that we cannot see stars at the distances that they tell us.
I am really trying to like believe that the flat earth exists. I would honestly not be surprised if we were on the back of a floating turtle, right? So here's the thing. The problems is that I can tell we're spinning because I've looked up. Like the moon, again, I told you I've been looking at the telescope. There was a time I would just stare into outer space. I saw a satellite fly over because it was just at twilight and I was able to see the light reflect off, but it wasn't dark or it wasn't light up. It was like because I was staring through the thing, it wasn't even lit up. It was nuts. I've seen the moon. I've been staring at the moon and I saw an asteroid hit the moon with my telescope. It's not electric. It's just a giant 6-foot thing. I was staring there, a little flash and then a puff, a cloud, and then it was gone. And there was a crater right there. And I was like, oh my God. And so I've stared into space. And the biggest thing, Dave.
So you're seeing a light in the sky. You saw a puff and you are convinced it was an asteroid hitting the moon when no astronomer else has ever caught that. But maybe you did. Let's just say you were extremely lucky.
Wait,
so here's the question. Here's the question.
A lot of times.
Here's the question.
Been caught hundreds of times, at least, easily.
So
that's a lie, Dave.
So
that's a lie.
What?
That has been recorded multiple times.
I haven't seen it, so maybe I'm mistaken. But so let me ask you a question.
I'm an amateur astronomer.
I'm going to ask you a question.
Old flat earthers is they don't care to look up for the answer.
You're a straw man because we look up all the time. We send balloons up. How many balloons have you sent up to 100,000 feet? Okay. Here's the sun. Let me make a point. Here's the earth in January. Okay. In June, we're over here. How many miles have we gone from here to here? 186 million miles.
Wow.
That's just from June, right? And then we come back another 186 million miles back to where we were. But at the same time, I need to make one point. So we moved this side to this side, 186 million miles. At the same time, we are traveling through space 4.4 billion miles. Billion with a B. Okay, do you know about the Georgia Guidestones?
Yes, I know all about them.
You know about the hole in the middle. And you look up and what do you see? You see Polaris.
Oh. Okay.
How can we move 186 million miles side to side and 4.4 billion miles every year without ever returning to where we were before? And Polaris never moves from that hole. Now you have two choices. One, Polaris is stationary above us, fixed in the sky, and everything is spinning around it, which would create perfect circular trails. Or I'm making a point. I could finish my sentence. I see you waving. Okay. Or we're corkscrewing through space and somehow, I don't know how the heck does Polaris stay in that hole?
Okay, well, you only provided the two options, which is a straw man.
What's the third then?
One of the...
Give me a third.
I would like to answer, right? Which is the fact that the entire galaxy, the entire Milky Way galaxy is spinning.
So the entire Milky Way galaxy is spinning and everything is going in unison with us. So Polaris moves 186 million miles to the left and then 186 million miles to the right. Because the Earth is going that way, 186 million miles, and then it's going that way, 186 million miles.
And this is exactly it. Something is making these galaxies, these Milky Way galaxies, flat. And this is where the end of physics comes down. So the fact that you can point to Polaris being in the same spot, which our ancestors guided these megalithic things and creations to go, you know, the Tartarian mud floods, I'm all for that, Dave. But I'm looking up and I'm thinking, we're spinning. And you keep bringing it back to the globe model. And again, I'm trying to get a direct answer about the southern constellations with the
So,
crux.
so I explained to you about the crux that they're not looking, that it proves the globe not to be true because they're looking in different directions. You're not going to understand it here. I can point you to some videos where it's gone over in more detail, and then you could do the research. But I'm trying to get to the point. I'm trying to get to the point to show you we're talking about the North Star right now. You think it's possible that we can travel in 10 years 4.4 trillion miles or whatever the friggin' number is, and Polaris doesn't move. Now, I don't know if you know what your heliocentric answer is. The answer is it's so far away that the billions and billions and billions of miles doesn't matter because there's no parallax when it's that far away. That is your official answer, whether you know it or not. That's what science says. It's ridiculous. But here's the point. You can't see Polaris at the distance that they tell us.
Dave, just real quick, before you put words in my mouth, just like you actually did right now, that's the scientific answer that I subscribe to. I actually think the universe is 30.7 billion years old, not 13.7, whatever they say. So there's a lot of stuff that I know.
How does Polaris stay in its same position?
Because it's the northern star. It's right above the planet.
So as the planet goes this way, 186 million miles, it moves with it.
It's far away. It's
so far away that amount of movement causes no parallax.
The Earth is also tilting, right?
It's tilting towards Polaris. So it's tilted towards Polaris.
Dave, let me answer, right? So now you have Polaris in this part of this night sky, right? And then you have it over there in that part of the night sky, and then you have it over there in that part of the night sky, but it's visible all night.
It's visible all the time. It's in the same place all the time. You can't see it during the day, of course. But how is it that we move 186 million miles? The axis moves 186 million miles, and it still points at Polaris.
Because it's an small number compared to the fucking.
So I just need to understand. 186 million miles at the distance Polaris is so small that you don't notice that it doesn't move. There's no parallax. Is that your answer?
No, that's why you see it over on the other side of the night sky.
What do you mean you see it on the other side of the night sky? It never moves.
The season, right?
It doesn't move. In June, July, August, September, October, November, January, it's still in the exact same spot in the sky.
It moves in the night sky.
No, it does not. It does not move in the night sky. You're wrong. Before I was a flat earther, I was fascinated with the stars. I was looking up all the time. I took 4 years of astronomy. I got a metal pipe, and I bolted it to the side of my house, and I looked through it, and there was Polaris, and I went out there every night for like years. I'd look through it. Polaris was always there. If someone says, "Where's the North Star?" I go, "Look through the pipe." There it is. It never, ever moves.
Wow. Dave, I got to really disagree with you that one.
Okay. So cool. I'm glad you disagree.
Do the stars move throughout the year? Does the Polaris North Star move through the seasons?
Polaris never moves anywhere.
I'm asking
ever.
Tim, Dave. I'm asking Tim. I'm asking Tim.
These are like questions that can really only be answered with observation. I haven't done that sort of observation. I'm impressed that
you're telling me,
David has. So
you haven't watched it. Have you seen Spider? Have you seen, I don't know, Polaris move through the seasons of different parts of the night sky?
All I can testify to is that I've seen the night sky move throughout the night.
And so, Dave, you're telling me that you put a pipe in your house and you lined it up to where okay, so and a pipe was fixed to a specific spot.
Yes.
Which was like a table or like a...
No, there was a beam on the side of my house, and there was a not a telephone pole, a utility post, and I nailed it to that. I bent nails around it. It was held in perfect spot, so Polaris was always there. Forgot about it for a couple of years, went back and looked, it was still there.
Now, could you see Polaris during the daytime?
You can't because of the sky, because of this, if there was an eclipse, maybe you could see it. But you can't see it because the sky is too bright.
You only see planets in the daytime.
So, Rob, we
and you
can
see
we can
planets.
I just want to make it clear. Your position on your heliocentric model is that Polaris moves through the night sky. Is that correct?
Well, let me tell you, Dave, it's fascinating, but Polaris, you can actually tell which it's called the North Star. So it always points north, right? And
Polaris
so
doesn't point north, it is north.
which would imply it's going north, right?
Well, it's north. It remains north. It does not move ever.
Talking about semantics.
Okay, yeah, good point. And so the North Star at December 21st points with Orion's belt to where the sun rises,
You're wrong.
which I've seen it, but
The North
okay,
Star does not move.
but it's right next to Orion's belt. It's next to the Orion's
Orion is always the same distance from the North Star all of the
Correct.
time.
Correct. And on December 21st, it points to where the sun rises.
Okay, what does that mean that it moves?
No.
Okay. So are we clear yet? Are we going to agree to disagree, or are you going to realize that Polaris doesn't move?
That's because if on this globe structure, it's above it compared to the other constellations where it spins more, which is why the Crux constellation, which we're coming back to, the Crux constellation can be viewed in South Africa, the same time it's viewed in Australia, in the same southwest point.
You keep going back to that.
Happen?
I showed you that you were wrong. You don't want to hear it. Well, let's move on from that, because I'm trying to make a point which you're unwilling to hear, that you are talking about lights in the sky that you don't know what they are. You don't know how far they are. You don't know how big they are. And you think that dictates the shape of the Earth. I can prove to you that the North Star is not anything like they say it is. I can't hear you. I see you clapping. I'm just trying to make a sentence. You got to let me talk once in a while, but go ahead.
You put words in my mouth. That's why I cut you off. I said, I think the Earth is spinning.
Did I say you don't think it's spinning?
No, you had said that I think that it's a spherical thing, and
I
it's
didn't
a
say
rock.
you think it's a spherical thing.
I forget what it was that you had said, but it's
Right.
putting the things.
So
in
did
my
you get
mouth,
my
which
point? Because I never made it.
Okay, so you're suggesting that Polaris should be moving throughout the night sky. But none
No,
of
you are saying that it moves throughout the night sky. I'm saying it never moves.
I'm saying you're suggesting it should be moving through.
No, I never said that. I'm saying, hold on a second. If I understand what you're saying, hold on. That we're spinning and we're moving. My question to you is, why doesn't it move?
Because it's all spinning. The whole galaxy.
So
Milky
all
Way.
of the stars in the galaxy are spinning with the Earth. Okay. So
No, they're spinning around the Milky Way's black hole center, supposedly. But that's the direction that all the stars are spinning in the Milky Way.
So when the Earth moves 196 million miles that way, and then it moves 196 this way, Polaris does the same thing. Is that what you're saying?
Well, clearly you think it's fixated in one place at the same place every time.
Well, all observations show that Polaris never moves, and all of the other constellations are fixed in their positions, and they circle around Polaris.
Because the North Star is above them, Dave.
A North Star is above the what? Wait, above what?
The other constellations.
Oh, so the North Star is higher and farther than the other constellations? Is that what you're saying?
No, from the Globetard's perspective, Dave, I'll finish my point, is that if they're on this part, then they're seeing all this. And if they're on the northern part, then they're seeing this, which is where most of the people are living here. So we see this part all the time.
Right.
And this is the exact problem. You don't even understand this, Dave. I mean, well, I'm not in a bad way, but the question that I'm asking about the Crux constellation is that if we can see Polaris in the northern hemisphere all the time, but you can also see the Crux constellation the same exact way, I don't understand it, Dave.
You
I've been
can't.
looking up to.
It's not, they're not looking in the same direction. There's only one day a year. Well, that's for the 3 locations, the 2 that you're talking about. But if you got 2 locations here and one's looking southwest and the other one's looking southwest, they're looking in different directions. Okay. But the point I've been trying to make for a solid half hour now.
That's a false argument about it, because there has been a actual video of 2 people.
I saw the video. It's by Globy McGlobeface. I get it. He's a diehard deceiver. Okay.
Okay. All right. I'm sorry for wasting your time with this. If you want to move on.
I'm trying to make a point that you're looking at lights in the sky, assuming that they're planets and moons and doing orbits and stuff, where I'm going to try to prove to you that you couldn't see them if that's what they were. Now, I talked about the inverse square law of light. You think that a gassy Jupiter, if you were on Jupiter, the sun would be very small. It'd be much smaller than you see it from Earth. So you believe that a small distant sun can light up those gases. They reflect back to your eye here on Earth, and that is bright as the sun. Jupiter literally is as bright as the sun.
I never said that.
No, I'm saying that. I'm saying when we look up at Jupiter, that little piece, it looks like a little piece of the sun. It's as bright as the sun. It's just tiny. And you believe that's reflecting a distant, smaller sun is reflecting off of that and going all the way back to our eyes, ignoring the inverse square law of light, because in space, I guess it doesn't matter according to you. But, that's just because of your lack of understanding that when light spreads out through gas or through an empty vacuum, it spreads out. And when it spreads out, it gets thinner and thinner and dimmer, and it gets to the point where it's so dim you couldn't see it. But the other problem is with Polaris is the angular size. You know about scaling and size? Go ahead.
Yeah. You just put all those words in my mouth, right?
What did I say that's not true?
I honestly don't know. I told you we could be on the back of a turtle.
So you're throwing out non sequiturs there right now. I'm only stating facts right now. Okay. And then you're claiming I'm putting words in your mouth. If you don't like facts, then what can I do?
Hold on. The facts, Dave, the facts are perspective. And this is a very thing. I like this conversation. This is good conversation because I'm trying to understand this better. And the thing is this perspective that we have, right? Maybe, with multi-dimensions, like you are living on a flat Earth. But again, the Southern Crux constellation, which I told you I was not going to bring up, it's hard for me to grasp that. But
okay, let's talk about what you're talking about. This is the 5th or 10th time I'm trying to bring up a point. Unfortunately, it doesn't seem, this is not an insult, but it doesn't seem that you're able to go more than 30 seconds without interrupting. And I want to make a point. I don't know if you're able to conceive it, but I'm going to try again. Okay? Do you know what scaling and size is? Like the moon, the sun is 400 times bigger than the moon, and they tell us it's 400 times farther. That's why they look like they're the same size. Do you agree with that? Or maybe they're just the same size?
Go ahead, make your point.
You live in the heliocentric model. You have to believe that the sun is 400 times bigger than the moon and 400 times farther, which is why they look like they're the same size. Can you agree with that?
I don't think they look like the same size, but I mean,
they're about the same size. Do you believe that the moon eclipses the sun during a solar eclipse?
I've been in a total eclipse, and it was fascinating.
Do you believe that it's the moon that eclipses the sun?
Eclipses the sun?
When there's a solar eclipse, what's blocking the sunlight?
The moon.
Okay. And when there's a total eclipse, is the moon approximately the same size as the sun? Appear to be.
Well, it appears to be.
Okay, but it's not because it's.
I was in totality. I was in the literal dark spot of this tiny little region where there was the umbra or whatever they call it. The shadow.
Congratulations. You're not hearing my point.
I've experienced an eclipse.
You've
Dave.
experienced it. Congratulations. This will make you an expert on what I'm asking you. Did the moon cover the sun so much that you didn't know where the sun was, or were they about the same size?
I was in totality.
You
which is what I
keep
told
telling me that. I know.
because that was literally the shadow of the moon, Dave.
Great. Do you want me to can I have your autograph?
No, actually, you can go to Niagara Falls in 2024 and experience it again.
Okay. I don't give a fuck. I'm trying
I
to
can
make a
tell.
point. My point
I
is,
can tell you don't care.
can
Dave,
you answer the question? Answer the question.
Which one?
Does the moon appear to be the same size as the sun?
It was like larger. Because
How
I was
much
in the
larger,
shadow.
percentage-wise? Because
I
you saw
couldn't-
the ring of fire, no?
I couldn't tell it was dark. I'll send you the videos. I took
I
video.
don't
of it.
care. I don't care. My point is, when it's eclipsing the sun, it's about the same size. Can you agree to that?
It was larger in my perspective.
How
at that
much
time.
larger? Was the sun like hidden behind it for 10 minutes?
It
How-
covered the entire sun, and it was entirely dark in the forest in Detroit Lake, Oregon, in 2017.
Okay, so when the totality happened, how long was the sun hidden?
I was in a region that lasted for about 3.5 minutes.
Okay, so the moon is moving very slowly. So the moon, if it's larger than the sun, it was only like a couple percent larger, and that's why as it passed over, it blocked it for a little bit, and then it popped out. Right? Is that what's happening?
Yeah, and you know what? Now that I think
Is
I
my question is, so I'm going to put words in your mouth. We can agree that the sun and the moon were looked approximately the same size. Okay, I hope you can agree with that. My question to
it
you
was larger. It was larger. I'm
How
trying
much
to tell you.
percentage wise?
Go in 2024 to Niagara Falls
God,
and
I'm
witness.
talking to you right here, right now. Was it 100% larger than the sun? Was it 10% larger than the sun? Oh, so it was twice the size of the sun.
It was larger than the sun, and it blocked out all the sunlight in totality. I don't. Okay.
So, okay.
We're gonna have to.
You know what? It doesn't matter.
Right?
No one has ever witnessed that except you. But let's say it's true. So hold on.
What?
Hold on.
Dave, Polaris stays in the same place, and I've only experienced the totality of the eclipse. Hang on, I only got 15
That's not what I
minutes with you
said.
left.
Not what I said. I'm trying to make a point. We haven't gotten anywhere. Try to follow me. Okay. So you said the moon was bigger than the sun. It was twice the size of the sun. Yes. Okay. In the heliocentric model, is the moon twice the size of the sun? Do you know?
No.
No, it's not.
No.
How many times bigger is the sun than the moon?
Did I say it was that? Or are you
I am
trying to get
asking you a question. Hey,
Dave,
Rob.
hang on.
Rob, I'm
15
asking you a question. I'm asking you a simple question. In the heliocentric model, what's bigger, the moon or the sun? Am I talking to a
so-
5-year-old? What's going on here?
No, we're talking different languages.
Rob,
Dave,
I'm
and I
asking
think
you a
you're-
simple question. In the heliocentric model, what's
No.
bigger, the moon or the sun?
The sun.
Okay. Is it twice as big? Is it 10 times as big? Or is it 400 times as big? Or something different? Okay.
I really
I will tell you, in the heliocentric model, they say the sun is 400 times bigger than the moon. That's what they tell you.
Okay.
Is that something you can agree with?
And I'll just because we only have 15 minutes left, Dave. I really wanted to get to more stuff.
I want to
But the
make this
thing is-
point, and if you allow me to make the point, you can spend the rest of the time doing whatever you want. I'm still trying to make a point that I normally do within 1 minute, but we've gone
It would be-
45 on this point.
It would be 2 times bigger if it was closer. But let's just agree to disagree about that.
No,
okay?
we're not
'Cause I need-
agreeing or disagreeing. I'm trying to make a point. You're unable to understand it. We're staying on this until you listen.
I need to go on to something else, Dave.
The sun is 400 times bigger than the moon in the heliocentric model. Can you agree
How
to
much
that?
further? What did the globetards say? How far away do the globetards say the sun is?
93 million miles.
So that's a pretty far distance, Dave.
This is my point. Follow along. The reason it looks like they're about the same size is because the sun is 400 times bigger and 400 times farther. That's why they look like they're at the same size. Can you agree with that?
Okay, yeah, I'm wrong about it. I'm wrong about it. You're right about it. You win. I'm
It's
sorry
not
for trying
about
to
that. I'm trying to make a point. Still haven't made it.
No, because it doesn't make sense. I really wanted to cover another thing. Please,
You know what?
Dave.
I will not even make my point because if I do, I don't think you'll understand it. It's pretty simple, but go ahead. Change the topic. And don't go back to friggin' the Southern Crocs because you're not going to let me make my point. I'm done with your point.
Thousands upon thousands of flat earthers believe that you can see further because you can see across the lake in Michigan and across different lakes. And the thing is those are all above sea level. So the only true curvature test is at sea level, which ironically flat earthers did in the hit piece. And I'll agree, it's total smear piece, the Netflix documentary Behind the Curve. At the very end, they literally had to raise it above their head in order to see the light. You know what I'm talking about?
Well, dude, you don't know what you're talking about because in order for it to see the light, if the Earth was curved, they'd have to raise it 27 feet. But I don't think my hand reaches up 27 feet.
That's perfect, Dave. That's perfect because that was their defense, right? That was their defense.
There's no defense needed. It was a hit piece that took everything out of context.
Sure, it was a hit piece. I'll give you that. It was entirely a hit piece. But in that experiment, did they have to raise it above their head?
Do you know why they had to raise it above their head? Because there was a tree in the way. There was a tree in the way. They didn't know there was a tree in the way. They were doing it at night.
So it wasn't done at sea level. It wasn't done at sea level.
It was. It was done on next to a canal. There was a tree blocking the light.
So here's the problem with all these tests, Dave.
Wait, hold on a second. Since you brought it up, did you know that after they brought it back down, they could see it again, but they cut that out of the film? Have you seen the mirror flashes? We've done mirror flashes at ground level, mirror on the beach, and we could see it 15, 20 miles away. I forget the distance, where there would be, a 6-story building in between them, and they could see the mirror flash. Okay? So you ignore stuff like that, and you want to go by a Netflix hit piece documentary.
No, I don't want to go by the Netflix hit piece documentary, but I want to go by what he actually said in the podcast that defended it. And he never said that there was a tree in the way. I don't even remember him saying that. He said that they had to raise it above their head. And then he defended it and said that he had to raise it. Well, it's not the 23 feet that it should have been. But, well, of course, they had to raise it above their head. Like, you know what I'm saying here?
So here's the thing. You're bringing up a Netflix hit piece. You think that flat earthers prove the curve of the earth when everyone there, globers and flat earthers together, walked away and said, you know what, too many variables. This didn't prove anything. But if you really looked at it, it kind of proved that there is no curvature. But we all agreed to walk away and say that it was a bad result because the laser, it was supposed to be done with a laser, but the laser melted. Okay. And that's why they were just doing a little experiment with the light, and it was taken completely out of context. Look up the mirror flashes, right? Excuse me. On my app, there's the frequently asked questions, and there's where does the sun go? There's mirror flashes in there, right? You know, like if I'm flashing the sun at you with a mirror, excuse me, with a mirror.
All right.
If there was a 6-story building in between you and the mirror, could you see the mirror flash? The answer is of course not. But that's how much curvature there should be.
Okay. I'll just say this real quick. You know, like, again, I was trying to express that I am very open-minded.
You're actually not, because you're unwilling to hear good points that would totally take apart your arguments. But you're bringing up really crappy arguments and unwilling to hear the evidence that will completely destroy them. Unwilling or maybe unable, I'm not sure.
I don't know. Honestly, I mean, I think that, 9/11 happened, and this is why I'm so passionate about it. I'll be honest, so many people that I've had this debate with have all pointed me to you. they've all said you got to talk to Flat Earth Dave about this because these questions that I've tried to pose, they can't answer. And so that's why I
Wait a
went there.
minute.
And here's
How
the
do you
thing.
know they can't answer? Because you couldn't hear a single thing I've been saying. I haven't answered one of your questions because you're unable to hear the evidence that I'm putting forth. So when you go talk to the next person, you're going to say Flat Earth Dave couldn't answer it either. The answer is you couldn't understand it or wait long enough to hear the answer. That's the truth. That's what's going on here.
Look, Dave, I look, all I really want, like, honestly, you can throw these things away. I don't care. I just love these conversations. And honestly, I was really trying to give you a chance to convince me that Flat Earth was real.
But you didn't let me make a single point. None. Zero.
Because the points you made,
I didn't make any points. I never finished the point.
Okay, you said that Polaris was fixated in the sky. I said that was because the entire galaxy is spinning.
Yeah,
And
how
the
does that
reason why-
work?
Well, see, here's the thing, Dave. You think that Polaris is fixated in one place in the night sky.
And you think it moves a bit through the night sky. Okay, so after this is done, do some research, and then when you find out Polaris doesn't move at all ever, that the Egyptian pyramid has a chute that points at Polaris, and it still points at Polaris. Okay, that the Georgia Guidestones had this hole points at Polaris, right? And you don't even understand that we're moving all of these distances, but we're also precessing, right? Every 76 years, we're moving a degree. Well, Georgia Guidestones were up for 40 years. That's a half a degree. That would knock Polaris way out of that hole, but it didn't.
Wait, what do you mean it would knock it out of the hole? You could find it in the night sky every time.
Yeah, but if the Earth is precessing 1 degree every 76 years, 40 years...
You can still find where it's going throughout the night sky.
But not through a station, not through this hole. This hole's not precessing.
You
move this a half a degree to point it at Polaris again.
The moment you point it at Polaris from your perspective, it's right there. So it's already in
But if the Earth, if I point that at Polaris and then tilt the Earth a half a degree, it's no longer pointed at Polaris.
Okay. Look, hey, hang on, Dave, I really love you. And I'm sorry that you think that I'm really like, this is the type of conversation I really like to have.
You keep saying that, but you're not really having a conversation.
I would have to agree with that. I mean, I feel like Robbie is like being very dogged and, you know, I think Robbie, if you want to make a counterpoint, you really have to make a kind of a coherent counterpoint and then allow another counterpoint to come on. But I think David has kind of nailed it here, really. And
let me ask my other question really quick.
Go ahead.
Okay.
David, you said this app is a bestseller. How much money have you made from it?
One, it's none of your business, but two, all the money I make goes right back into the app.
Which you continue to sell to people.
Oh,
what difference does it make? Do you work? What do you do for a living?
I want to have the app. What's the app?
Oh, it's called the Flat Earth, Sun, Moon, and Zodiac Clock app. Email me after the show. I'll send it to you for free.
Okay.
I would say you have a conflict of interest because there's nothing I could ever say to you that would convince you otherwise now.
That's not true. Say something coherent.
You're offering 2 Bitcoins. And
3
and
Bitcoins.
Like
get your shit straight, man.
3 Bitcoins. I'm really sorry. But I don't think you'd even give 2. I don't think you'd give any. I think that you're so far involved into it. And let
give me a globe proof besides the Southern Crocs that I can prove to you if you listen, but you won't. You can't see these things that you claim are stars and moons and planets.
So you're not going to believe that I can see the 4 Galilean Jupiter?
No, I believe that you can, but at the size and distances that they tell you, it's scientifically provably that I can't even finish a fucking sentence with you. Okay?
I'm saying I don't know how far Jupiter is. But
I know don't? That
no.
Well, then how do you know what it is?
Well, I know it's a planet because
how do you know it's a planet?
Because I can see it in the daytime.
You can see a light in the sky. You don't know what it is.
You can see planets in the daytime sky.
You
and
can see
can't-
lights in the sky, period. Right? If it didn't have any light, you couldn't see it. You don't know how far it is. The angular size doesn't work. The light doesn't work. None of it works.
You're forcing me into that belief. And it's like, I'm trying to unlearn this here. And you're just telling me it's straight wrong.
Well,
And I'm like, well,
the reason I'm telling you it's straight wrong is because you're unwilling to let me explain how it's straight wrong, because the explanation takes longer than your attention span.
I honestly, like, it does not make sense that you can see the Southern Crux constellation, which you say.
There you go again. What is the Southern Crux constellation? How far is it? What is it? How big is it? How is it possible?
That's not the question. All I know is that from verifiable proof, there have been people in Australia and in South Africa who have seen it.
What are they looking at? Are they looking at a reflection of a northern star? You don't even know what they are. You don't know if they're physical or anything.
Your answer to that is saying that I don't know what it is.
I don't know what it is.
Okay, well, I'm telling you that it can be viewed from now.
But I can prove to you it's not what you think it is. It's not what they tell you it is.
I'm going to shut up and you can prove it to me. Okay?
No, we're done. The show's over. It's over.
I'm sorry.
Listen, why don't you go research Polaris and find out that it doesn't move, and then reconcile that with the motions of our the Earth moving 196 million miles and then back, traveling 4.4 billion miles a year. And somehow Polaris perfectly lines with that on a spinning, wobbling, moving ball for decades and centuries.
Well,
okay?
Can I tell you something, Dave? I'm going to end real quick, and I'm sorry, I'm just going to end it with this. Honestly, I feel like you're trapping people on this flat Earth. I think that when we travel through the double helix way, we're creating a three-dimensional double helix, which is a thing to life, which this universe is all about life and promoting growth. And so honestly, I think that there's a lot there to learn. I think free energy exists, or 0-point energy should be.
I believe that too. Provable.
NASA,
how we have gravity.
Tartaria is totally real. I think the
sure on flat Earth doesn't make sense on a spinning ball. How do you mud flood a spinning ball?
I'm sorry I came off so, Judge.
It's not that you're unwilling to listen. I don't know if you're unable to process the information. Not sure. Don't know you. But it was a very unfruitful conversation because you just go like this the whole time. Like, hey, stop talking. I don't want to hear what you're saying. All right. But, you can believe whatever you want. And you can just believe if you never listen, and you don't listen at all.
Well, I'm looking up, remember?
I look up too. I took 4 years of astronomy. I was in an observatory every friggin' night, like 3 or 4 nights a week for 4 years. Okay? Way more time than you. All right? And I saw lights in the sky. I was told that they were things. But
Dave, you kind of have a big ego, and you really are assuming a lot of stuff about me. And I think I tried telling you that I've looked up my entire life at the night sky.
I know, and you were also during the totality of an eclipse, and the moon was twice the size as the sun, right? Go find me evidence of that somewhere.
But that was my perspective. I don't know what you're trying to mean by evidence.
The point I was making is actually worse for you if the moon was twice the size of the sun. I tried to make the point for a half an hour, but you just talked over me and waved your hands.
Isn't that because it's so much closer?
That was part of my point. I was trying to explain to you scaling and variance, but you were unwilling to listen, and so I couldn't make my point. We got to go. I got another interview.
Thank you, David.
You can find all my stuff at flatearthdave.com if you want to learn the truth, or if you want to believe this guy with a wandering Polaris through the night sky. Feel free, man. Peace.
Buy his app. He makes money off it.
I make money. That's so funny. It's horrible.
Dude, Nord Stream 2 and 9/11. Where are the real conspiracies that we should be talking about?
Hello everyone, Strawman Dan here. And before I start, I just want to tell you all about what is by far my favorite app of all time. Yes, you guessed it, it's the Flat Earth, Sun, Moon and Zodiac Clock app. I know, for years I have been anti-Flat Earth with my highly edited weekly anti-Flat Earth scripted rants. But after downloading this app, wow, I'm blown away. Earth is a horizontal level plane and I'm a complete douchebag. I'm sorry.